Hello, we're the four MASketeers. This is tedious for students to check friends' schedule to figure out what classes they have in common and set up time when they can meet together. Our app aims to solve this problem by introducing a mobile app where college students can share schedules with friends and organize events they can attend together. The first main question we have for this sprint is how useful is our implemented app? We interviewed 8 potential users with our actual app to get feedback and asked what are the most painful parts to use our app. The test results will be shown clearly below. The second question is how to monetize our app. We did domain research and use Google AdMob to add an advertising placeholder under the main page, and users can pay to eliminate the ad. Our application has real-time in-app friends management to help user add and invite friends, class querying from official third-party up-to-date GT class database for search and add course to calendar, persistent user schedule and friends storage, classic day-by-day schedule view to display added class and events, and custom events creation with friends invitation to make sure users can view their friend schedule and plan an event when they can attend together.
Our storyboard has not changed since last sprint, but to recap, we have a student named Jack wanting to have a last-minute study session for an upcoming exam, and he uses Schedule Pal to create an event for the session and invite friends to it. The only addition to this storyboard is the inclusion of ads in the bottom of the screen, a purposefully non-invasive position.
For our prototype here, we have a main screen which shows the current courses and events the user has on their calendar, a course share screen, and create an event screen, which includes an option to send friends and invite requests to an event. We also have an add friend feature where you can look up friends by their name, along with the current friend requests you have going in and out and a friends list. When the user selects the calendar icon next to their friend's name, you can also view your friend's schedule and compare it with your own. We also have an events list where you can view courses and events in a list view and be able to edit events as well as to see who you have invited to those events. Our testing process involved providing 8 interviewees with an Android phone that had the app pre-installed. We gave them tasks to complete and time them, as well as having them voice their thoughts about each feature and the overall app. We gave the interviewees these 3 tasks to complete with their times listed here. Each member on our team beforehand had already simulated these tasks and timed themselves, with our average falling under the expected column and the average of the interviewee's time for each task under the average column. Since the expected and actual time for each task were extremely close to each other, it just shows that our overall UI is intuitive and does not cause confusion. From the time taken for each task, as well as the interviewee's thoughts about the application, we found that it was easy to use our app through the simple and intuitive UI. We also received some criticism, such as the lack of visual confirmation on our course search page for when a course is added, and the possibility of inviting our friends to an event that has a conflicting time.
The future direction of our project aims at advancing user-centric aspects, including designing for context by integrating language references, local holidays, locations, notifications, and external calendars. Developer-centric aspects such as CI/CD, pipeline, and Docker for streamlined development, and project-centric aspects towards securing our app by authenticating users through the Georgia Tech SSO and API requests to our web scraping server. Our final business model canvas incorporates our integration of Google AdMob as our ad broker to present banner ads in our app to users as our primary source of revenue. This is the final software architecture of our mobile application. The app's Flutter frontend runs on both iOS and Android devices and interacts with our backend through gRPC for our Firebase database and authentication services, and through RESTful API for our Python Flask web scraping server hosted on Replit. Our latest development showcases the addition of Google AdMob service for generating advertisements.
Our team decided to develop our application for mobile platforms. And to ease the development process of this, we use Flutter for its shared code library for multiple OSs, and we have separate configuration folders for our chosen mobile platforms, iOS and Android. All of our code was broken up into different files for each screen, and we named these files according to the screen code they held. One specific code example we have is for our friends list screen. When writing our code, we chose to stick to the standard of modularity. As such, the different steps of generating elements on the screen are broken up into separate chunks of code, particularly inside of functions. For the friends list, there's a function for actually retrieving the user's friends list from Firestore, as well as the necessary information about those friends as users, a function to build the screen itself in the friends list container, and a function to actually build each individual friends list element to establish consistency and ease of reusability. And that is it for our presentation.